Yep, we're live. Hey guys, welcome back to another live stream. And this time around, we are doing this on a totally different time. And let's see how many people are interested during this time of the day, because it's almost like a 12 hour time difference from when we usually do our live streams. So yeah, I'd be interested in knowing how many people are active during this time of the day, or what time works better for more people that are interested in these live streams. But today we are gonna be working on the lower part of the robot's body. So we, in our earlier live stream, in the 12th live stream I think it was, we showed the upper body of the robot, which we have finished building, and today we are gonna start assembling the lower part of the robot's body. And we have all the actuators for one leg of the robot, and then we have three faulty motor controllers for the lower part of the other leg of the robot. And we have placed an order for those motor controllers, and they're going to be arriving soon. So but up until then, we are going to finish assembling entire leg of the robot's body, and we are going to build as much as possible the other leg of the robot. Yeah, so for anyone who's been following our series, we have already assembled the upper body of the robot. We've also done a basic testing of the upper part of the body, which I'm not sure if we have shown it on YouTube or not. Have you uploaded it on YouTube? We haven't uploaded any video, but in our earlier live stream we showed it on a mobile frame. Yeah, so upper body is complete. The lower body, because of issue with a couple of controllers, we were not able to calibrate both legs of the robot, but we do have one leg successfully calibrated and a few actuators of the other leg. So we have this hip area 3D printed for the robot, and we're gonna start assembling, and we'll assemble as much as we can. Yeah, I think before we start putting everything together, we need to make sure that all the encoders and magnets are attached, I would assume, on these motors. Then I think first step would be to attach these motor controllers on top of this actuator. Yeah, so the one like circle, so we've already written down all of the actuators for the leg. The tick means that they've been calibrated. All of these are ready to start the assembly process. For this one, the one where I mentioned a circle over here, I think this is the one where the magnet was wrongly attached with hot glue. Yep. Yeah, I think this is that one. So we're gonna have to open it up and correctly place the hot glue. But for all these actuators, they are good to go. We have them laying down over here, and a couple of them over towards the left as well. So yeah, we're just gonna start following the instructions from the documentation, and we're gonna start assembling these in this live stream. Yeah, so I'm gonna attach the hot glue gun, and once it gets hot enough, we'll fix that one. Okay. But meanwhile, I think we can start putting together. So yeah, to put together what we are also gonna record a video. So to make the video editing process easy, we need to bring all of these parts here close to the camera like this. Okay. And then we need to explain everything, how these parts are gonna fit on top of this groin, step by step, and then I'm just gonna cut. First of all, we're gonna pick the right size aluminium profiles, and we want to make sure that the size is right. This is roughly the right size as per their documentation and video. So I'm gonna take out aluminium profiles, and I'm gonna start putting in the screws and attaching this part with this aluminium profile. Yep. So I'm gonna use the same voice from this live stream as well. Okay. So whatever steps you are gonna be briefing the live stream on, they are gonna be used to make the video. So once again, guys, we are doing these live streams, but we are also recording summarized versions of these, and I'm gonna be setting up a playlist on my YouTube channel. We already have a couple of videos live on our channel regarding these the building process. So the videos we have live right now on our channel are how to assemble the M6C12 actuator for the robot and the 5010 actuator for the robot, and then we have some videos on soldering, how to properly solder the resistors on the encoder and how to put everything together. So we have quite a few summarized videos live on our channel, and the rest of the process we are going to be documenting that in a summarized video form as well. And then I'm going to be setting up a playlist on my YouTube channel specifically for this humanoid robot. So yeah, and we're gonna be using clips from this live stream to make those videos. Yeah, it's a pretty cold roughly afternoon time here in Tokyo. It's raining outside. The temperature is quite low. I think it was about 13 degrees last time we checked, and we have the 3D printer going in the background. If maybe you're able to hear its voice, we're printing some products for an experiment that we're doing, a small R&D project. And yeah, in the meantime we're gonna be assembling this today. I don't know how long. Ali, just a second. There's a heron sitting in front. Oh, wow. Oh, yeah. Don't move too much. If you can, yeah. So a heron just sat right in front of our window, and it's the first time it has come this close to our lab. Yeah, this is a small one. It's a child, I think. Yeah, I mean, let's try and show it to the live stream. So I'm gonna try and get this camera this way, and then I'm gonna bring it closer to the. So I don't know if you guys are able to see it out there. Is it clear? Yes, it's clear now. It's looking so cool. Yeah. By the way, it's pretty small in the camera, but in the real life it's pretty close, and it's pretty it looks small in the camera, but it's pretty close and it's pretty big in real life. So let's put this thing back on. Yep, it just flew away. So it was here to say hello to the chat. Yeah. And yeah, he just came in to say hello, and he's gone now. Yeah, it's the first time the heron has shown up over here. So we do have a pair of heron that comes roughly around this area. There's a lot of herons overall in Japan. So even in Tokyo, in areas which are close to the river, the Tama River and other rivers which are over here, as well as in the countrysides, there are a lot of herons here in Japan. No wonder they show up a lot in their folk tales and in their stories and poems. So a while back, the pair of herons that comes over here close to our area, they brought some kids with them, 3 kids. They were pretty small initially, but now they have grown a little bit. Yeah, so the heron we just showed you, it was one of the kids. Yeah, it was one of the kids. It was a small one. He's a regular, but he has never come this close to the lab we have set up over here. He's never been this close. So he just wanted to tune in for the live stream. Yeah. Okay, the charging port is attached. Charging. Yeah, these aluminum profiles are quite dirty when I have unboxed them. So by default they have dirt in them. Yeah, they have a lot of sharpeners. It's the case with all the aluminum profiles. So whenever you order these from China or wherever you order these from, usually they cut these to the right size according to your specifications, and they don't remove the sharpeners and anything like that during
dust.
packaging.
Even dust, it has a lot of dust in it.
Yeah, so you have to clean it, and you have to be careful not to drop those sharpeners around in your lab if you walk without wearing any shoes or anything like that.
Yeah, no, aluminium sharpeners are definitely dangerous. Yeah, so like I'm just having to spend some time cleaning this aluminium profile before we can start attaching it with the hip of the robot, the 3D printed part, which is over here. Once the aluminium profile is clean and it's ready to be attached, we're gonna grab the screws and the T-slots, and we're gonna start assembling the lower body of the humanoid.
Okay, I'm gonna go grab coffee now.
All right, it's raining a lot.
Yeah.
It's raining a lot outside.
Yeah, but I think we're gonna be live for another
Few hours.
yeah. We're gonna be live for a few hours at least, so I'm gonna grab coffee, and then we're gonna try to sprint, and we're gonna try to do it as much as possible, especially once the leg is done. We are gonna try and put the rib cage of the robot using aluminum profiles, and we're gonna try and place the PC and everything in there as well. So
Okay.
yeah, whenever we get the other motor controllers, we have everything ready.
Yeah.
Basically.
Yeah. I hope we are able to do that quick tonight. So I hope that in today's live stream we are
I
able
think we
to.
have a lot of time today, so it's just gonna be like sprint, sprint, sprint.
Yeah.
And at night time, I think we do need to sit together to
Yep.
do some of the
Yeah.
school stuff.
Yeah. Definitely. Definitely. Yeah. Once again, today we do have some time during the day. Previously we were quite busy during the daytime, so our
This is working, right?
yeah, it's working.
Yeah.
It's
So
working.
a few people are like tuning in for just brief moments of time. These are either, I think, different audiences or different batch of subscribers that are live during this time.
Or they are from the short.
Yeah, or they're probably from the short clip that we've just posted.
Yeah.
Yeah, if you're anyone is tuning in from the Joe Biden 3D printing short that we just pushed, let us know in the chat.
Yeah, let us know if you enjoyed it or not. It was just a random idea.
And let us know if you were able to figure out what Joe was trying to say over there.
Yeah.
This works, right? It's gonna work.
Yep, it's gonna work.
Okay, I'm gonna be back in a while.
Fine. Hey, just bring two. Yeah, two bananas.
Okay.
Yeah, so usually we are busy during the day. Occasionally on one or the other thing during the daytime. But today was a little bit free, so we are doing live stream at a different time as compared with our usual day. It's just a matter of getting a couple of hours during the day or the night when you can really sprint through a project continuously and cover as much as you can. So usually with this is like our 13th sprint in this series, and usually our goal with every single one of our sprint is to continuously work on one aspect of the project and cover as much as we can. So it's been the same case with our previous sprints where we built the arms of the robot or calibrated the actuators or assembled the upper body. It's been the same, so just spend a couple of hours. I think the maximum amount of hours we spent consecutively was around 4 hours in one sitting, or 4+ hours in one sitting. Today as well we hope to sprint through the lower body of the robot and assemble as much as we can. Last time around while we were assembling the upper body, we made a slight mistake, which was um, in the wiring. So wiring, soldering, yeah, and just the wire management in general. When there's a lot of actuators in total in the upper body and lower body as well. So in general the wiring was a bit messy, and the placement of the wiring, the routing of the wiring, it was not very good. So we had to open up the arm a little bit, resolder some of the parts. Some of the parts were breaking because we had assembled it in quite a rush, in a sprint. So we had to reopen some of the parts, resolder, reroute the wires. So this time around, while building the legs, we're gonna try to make sure that the wiring, the routing, as well as the components placing is correct from the get-go, so that way we do not have to open up the parts again, and everything is compact and tight. Alright, so what we're gonna do is I am going to place this hip portion of the robot, um, and I'm gonna attach this with this aluminum profile. And for that, what I'm gonna be doing is inserting T nuts from here and screwing them from the top from here in these holes. So I'm gonna grab some T nuts of the right size, as well as some screws with the right length that can go inside of them, and we'll test and see which size fits for these ones. Let's bring in some T slots, T nuts. So these are M3X20. I think these are gonna fit in well, but we're gonna have to obviously try and see. I think that they might be a little bit longer than the size that we need for this one. They might be. In which case, maybe some parts from here might work out. These are M3. Yeah, I think these are M3. We do have some T nuts over here, M3. We're gonna open these and let's try putting one of these together. So I'm gonna insert this over here like this, and okay, so before that we need to make a T joint on this aluminum profile as well. So we need to grab a smaller one. Let me see if I can find it somewhere over here. One, two, three. This one. So what we want to do is we want to join it like this over here. Okay, so for that I think we're gonna be needing to use M4. screws. So I'm gonna grab some M4 from here. So M4. As much as I want to sprint on this project as much as I can today, even beyond like 4 hour 5 hours, we do have some other tasks today as well, which we're gonna take care of during the later part of the day. So let's see how long we're able to continue today's live stream and how long we're able to sprint on this project today, because later on we also have a few other tasks to take care of today. So I'm just looking for the screws which are the right size for this part. M4. Let's first of all grab M4. Alright, M4, and now the screws, maybe somewhere from here. Yep, this one is the right size. So I'm gonna try assembling all of these things together now. I think this is a little bit longer for the aluminum profile we have. This is definitely a bit longer. Let me see if we have short ones but the same thickness. Yeah, I think these ones might just fit in properly. Yep, these seem to be the right size. So I'm gonna try putting them in now, and I'm gonna try connecting this part. Here, and put this in. And put this in from here. Okay, there we go. Goes in like this, and this is how it will attach with this part. So we need to do the same over this end as well. Put in a screw from here and a T nut from this side. So let's do that. um, M4 size. I'm gonna take this one out. It's the same size. Yep, seems like it. By the way, if you guys notice, there is a small avatar at the bottom of the screen somewhere over. As you can see, it's right. Yeah, it keeps disappearing. There's this small avatar at the bottom of the screen, and if this will appear for anyone who sends a comment. So for if you guys submit any comment, if you want to talk about anything, maybe robotics related, technology in general, or software, or just want to leave a comment, an avatar will appear with your name and comment at the bottom of the screen as well. It's a really fun feature we thought of adding a while back. So yeah, if you want to leave a comment, any comment in general, feel free to do that. So I'm just gonna continue making these connections for now. Add this part. By the way, in the Berkeley Humanoid Light, which is a robot that we're building, in their official document they're not using this part. The reason we are having to use this part is we're having to use a workaround because our the order for the parts that we place, it's getting a bit delayed, and we don't really want to delay on the project. We have a set deadline in mind where we want to finish this project before that deadline. So we're just sprinting through the project, and we're using our own custom parts from the lab wherever we can. So all of the parts in our robot are not exactly in accordance with the Berkeley Humanoid Robot documentation. So for example, they're using different 90-degree connectors for aluminum profiles, but it doesn't really make much of a difference. We just have to connect these parts like this, but this part is not exactly as per their documentation. So I'm just gonna move this a little bit to ensure that this aluminum profile goes in.
Yeah, by the way, we almost got copyright striked. So we have a friend who works outside of the lab, and he's also working on some hardware stuff, and he had a koali playing on loudspeakers, and the voice was so loud, and I immediately turned it down. But if that voice got recorded anyway in this microphone, I'm afraid we'll be getting a copyright strike. But the sensitivity of our mic is pretty low, and he's working at a little bit of distance. I would say about 100 meters or 150 meters away from our lab. So I hope the voice was not recorded in this live stream.
Yeah, hopefully not.
Someone dropped a like on our live stream. Thank you so much for supporting the live stream. And if you're here, let me know if you're working on any interesting projects, and if you have any interesting ideas for us to try after finishing this robot.
Yeah, or if you have any questions in general, feel free to send a comment. A cool avatar will appear at the bottom of the screen with your name and the comment. Alright, so this is how we need to make the connection. I'm just gonna grab a screwdriver now and I'm gonna tighten these connections. Can I have like the long and powerful screwdriver, the one that we had? Here it is, here it is. So this screwdriver, I'm just gonna tighten these screws roughly at the center.
Guys that are watching the live stream right now, let us know which part of the world you guys are from, and how's the weather over there, what time of the day it is over there. Here it's raining cats and dogs, and I think it's gonna be the same way throughout the night as well. Right now it's about 1:40 p.m. around that time, and usually at this time of day we are busy with other stuff. We usually push our live streams to later part of the day.
Yeah, when it rains in Tokyo, it really rains. And it's just a constant moody sort of an environment throughout the day, throughout the night, continuously, sometimes even for weeks. Sometimes continuously even for weeks. It just keeps raining at a constant pace, and it's a very gloomy, monochrome sort of an environment here in Tokyo.
But if you love rain, you guys are gonna enjoy this kind of weather. Also, we are staying right next to the ocean, and the birds that are here usually that are looking for fish and other stuff to catch from the ocean, they're still here during this rain. No matter how severe the rain is, they always show up.
Yeah. That's a really fun aspect about this. The birds, it doesn't matter what the weather is like, they're always here.
Yeah, so I
Every
think squirrels and some other animals, they usually like stock up their food in their houses or in the trees and stuff. I don't exactly know if squirrels run around in rain looking for food, but for the birds that get their food and fish from the ocean, they always show up during the rain as well. So the heron that showed up next to our lab early on, we also showed up in the camera. He's still there. He's still looking for fish, and he's gauging the situation, and the dude's not worried about like catching cold or anything like that. He's just like his stomach is driving the whole day.
Okay. I'll need to change this a little bit. Take this out. So from here.
Yeah, I'm not sure if the views that we got, if they're from the short. Let me actually see how the short is performing. Let me try and see that. Okay, so it's at 103 views right now. Yep, it's going exponential. Yeah, so I don't know where with YouTube videos and the videos you upload to YouTube, they usually they go somewhat exponential for a while, and that's the initial push the algorithm gives to your video to viewers, which it thinks will engage with the video, like the video. It's almost like a shot in the dark if you don't have a well established channel yet or a user base viewers base yet. but after that usually all of the videos you upload to YouTube, they sort of flat out. So the algorithm gives it any initial push, and usually if you don't have a big channel, the response to the video won't be as great, or a lot of people won't be interacting with the video, and that's where video ends up going flatline in terms of its reach. So yeah, we just uploaded a short, and it's also being pushed in the algorithm, and I think quite a few people watching that short, they are also tuning in this live stream, having a look around.
Okay, so like there's a small issue with this part that I have been working so hard on for the last 20 minutes. As you can see, it's not exactly 90 degrees. You'll be able to see it's bent slightly towards the left side. So I'm gonna just fix that now by loosening these screws a little bit and adjusting, because
How
on one
will-
side it's a little bit
How's this part gonna fit into this?
it's gonna fit in something like this.
So,
And then
I mean,
yeah, this will go with the
Are,
upper
are,
body.
are these corner brackets, will they like
Or maybe like this. I'm not exactly sure. We'll see in the tutorial. Later
yeah,
on.
but I'm just wondering if these corner brackets, they block the path for the 3D the PLA or anything like that.
I don't think so. Let's see.
Yeah.
We'll get to that stage in just a few minutes. Okay.
Oh,
loosen this.
I didn't set a goal. Let me do that now.
Loosen this.
The first
Loosen-
super chat,
okay,
and
over here. Roughly around the center, yep. And it's roughly 90 degrees now.
yeah, I think this is good enough. I don't think it needs to be perfectly aligned for the robot to move or anything.
Yeah, I don't think so either.
Yeah, so in their documentation, they are attaching everything with inner brackets, and I think that's gonna show up as a problem later on. Right now we don't have the correct sized inner brackets, but I think they should be arriving sometime soon.
Okay. So
Yeah,
he's
so
picking up
so
this
as you can
part.
see, yeah, this is how you're gonna place them, and it's of course it's not gonna go in. Yeah, that's what I was saying. And let me pull that up. Oh yeah.
Okay, so this is gonna be a problem.
Yep. So we don't have the right sized aluminum. Sorry, the inner brackets yet. So
Let's see.
I
if we're
think we
able
can
to
move forward. Yeah.
if we can continue with the next steps.
Yeah. We're gonna try and continue with the next steps. That's what we're gonna do now, and. Yeah, I think the next step should be grabbing the correct actuators for this part of the body. Yeah, so I think grab the actuators for the legs. And we have to be careful with the
Orientation of the legs.
yeah, the orientation of the legs, the left one and the right one. Yeah, just grab one and disassemble it.
It's already disassembled. This is the one, I think. Yes, 10 upper leg YL. So if you can see over here, 10 upper leg YL, it's already disassembled. However, we want to make sure that we are attaching this on the right leg. Not right leg as per se, but the correct leg.
Yeah.
So this is the left, the entirety of these that we have is for the left leg. So first of all, we're going to figure out where the left leg is. I think it's this one. If the orientation is going to be this way, right?
I
then
mean,
this
you
is-
can look at the entire body and figure it out.
Yeah, let's take a look at the full body image. The robot.
So we have all the actuators ready to go, but we're just making sure the orientation for the actuators is correct in terms of left leg and the right leg. We don't want to get confused between the two, otherwise we're gonna run into problems during the software stage.
Yeah. Can you hand over the mobile phone up there?
Yeah, so we are gonna be disassembling these parts first of all, and let me
Okay, it's like this, right? Yeah, I'm pretty sure it's like this. The orientation is like this.
yep, it looks this way around. Yeah.
Okay, and then this is the left leg portion. This is where we're gonna be attaching all of our actuators and building the left leg from here onwards. So yeah, let's focus on this one.
Yeah, so the first step will be to disassemble this part over here.
Okay, let's watch over here. Oh, they're also putting an aluminum profile.
Yeah,
on this part.
It's just for like putting it, attaching it to the upper frame. We can do that later on.
Okay. This one, right? This one.
Yeah.
And
So just disassemble this part and use this screwdriver to remove everything. And for tutorial as well, you need to like explain these steps, so I can just cut it out.
yes. So I'm gonna be disassembling this part of the actuator, so that way I can attach it once again on this hip area of the robot, which we need to attach it for assembling the lower body of the robot. So I'm gonna disassemble this. Here as well. Bit tricky to take this off, and I do not want to break anything. There we go. Okay.
You have to push it to the opposite side.
Okay. Let's see. All right. And now we want to put this once again here.
With the bearing or without the bearing?
So first of all, we need to take out this bearing. We need to take out this bearing, and we want to insert it in the bottom part like this. Okay. Right. And now this part along with this bearing, we can take this out now because we already have a bearing over there in the other side. Now put this inside of here.
It's in there, yeah.
Okay. Now this bearing on top of it here.
And then the lid.
Okay. And the lid comes here on top of this. I'm gonna make sure that the holes are correctly aligned, for which I'm gonna grab a tool. Like this, and I'm gonna just push this on top of this upper part, and you can see it's firmly fixed with this part, and similarly a lower lid as well, I'm assuming, right? We also need to attach a lid
We
over
need to
top.
attach a lid over here as well.
Okay, I'm gonna pick the other lid from here, align this as well.
Yeah, make
With
sure
the
the two
upper-
bigger holes are aligned as well.
Yeah, they are aligned.
Okay.
And just I'm gonna align this one as well.
Yep. Then we need to grab M3X60 screws.
Okay. And now this is the calibrated actuator that goes on top of this. As you can see, it's 10 upper leg YL. This is first actuator, M6E12 actuator. So it's M6. And this is the one that goes as the first actuator on the left leg of the robot. So it needs to go on the robot something like this. So like this. Okay. So for that, we're going to be grabbing some screws as well as a hex insert to add over here. Can you pass over a hex insert?
I'm gonna prepare it now. So
Okay.
I'm gonna attach tape to that hex insert.
Alright.
Yeah, so we were not wrong on the last two bearings part. So the last two bearings were actually not with us. Right, for the entire entirety of the robot design. I'm gonna try to make it bigger if possible. Okay, this much should be good enough, and let me put this over here as well. And okay, so I'm gonna prepare the hex insert. So
Yeah, and I'm just gonna put
Yeah,
these
so-
screws in the meantime.
this is the hex insert we are using, and once again this hex insert, it's not the right size, and it does not snug in perfectly to where it's supposed to go in the design, and that's why we add a little bit of masking tape around it to sort of remedy that. The little bit of we by using the masking tape, we add a little bit of extra diameter to the outer walls of this hex stand, and that so it tends to kind of fit perfectly where it's supposed to, but it's not a perfect solution. I'm gonna need the scissors. So where are the scissors?
I'm not sure if this is the correct size screw or not. It seems to be a bit short, but we're gonna
You can use the vernier caliper to check it. We do have.
bring in the vernier. So I'm gonna use the vernier to check the size of this screw.
Every time I go live, I really wish I were live on Twitch as well, along with the. I'll set it up one of these days.
Yeah, it is 60. So it is the correct size, but for some reason it just seems too small. Put this one in as well.
Our tools are all like.
By the way, guys, there's a very interesting 3D print going on in the background. I think it will take maybe 10-20 more minutes to finish. Once that is finished, we will showcase that on the live stream as well, what we're up to, and a very interesting thing that we're building. Oh, so this screw was actually short. As you can see, there's a difference in the length of both of these, so I'm going to remove this one. It was indeed a bit short in length. We do not need this one. How do I put it aside from the rest of the screws? Maybe over here.
Yeah, just throw it to a side now. We're gonna clean up the lab after once we're done with today's live stream. And I think we're not gonna be needing these cleaners and the aluminum profile for this today's session as well. I'm just gonna remove these as well. We only have 6 of these hex stands, so that means we'll only be able to attach 6 actuators right now.
Yes, 6. Yes, 6 is enough for one leg.
Okay, so we'll only be able to attach one leg this
Yeah.
time around. Yeah, make sure to like every single step, make sure to document it for the video we're gonna be editing later on.
Yeah.
Otherwise, we're gonna have to redo everything for the other leg while we're joining the.
Yep. So right now I am inserting these screws, which are 60 mm in length. I don't know exactly what is
M3.
M3. So like M3x60 screws. I'm inserting them from this end, and then we need to attach the motor over here and screw everything in. So for now, just push these in.
So I have attached 2 layers, almost 2.5 layers for the masking tape. So yeah, so this is what it looks like when the masking tape has been applied on the hex stand, and now the diameter of this hex stand is slightly bigger, ever so slightly bigger, but it tends to sit in its place way much nicer this way around.
I'm just gonna beat the screw inside of the 3D printed parts.
Yeah. And then to align it, you're gonna have to push them back.
Yeah, I know. Okay, so as you can see, we have all these screws inside. And yeah, with that, now let's attach the motor with this part finally. Do you want to insert the motor?
uh, which is the correct motor for this part?
Yeah.
Is it the 10 upper YL, 10 upper YL?
I think that
I'm
this
gonna
is the
move
one.
the remaining to the side for now.
Okay. Yeah, by the way, we were not expecting these many views to come on this live stream because it's too far out from our usual time. Usually we are live roughly at a 12-hour difference from this time. 10 to 12-hour difference from this time. It's our first time doing live stream at this time, and the views are pretty much the same as our live stream during the night time here at Tokyo. Today our day was a bit free. We did not have many tasks to cover during the day. We do have some tasks, but we're gonna cover them towards the later part of the day, evening or the night time. So yeah, we thought of coming live during this time to make some progress to this project.
Okay, so this is the motor. I have now pushed back all of the screws, and now we are gonna align this motor here with the other unit of the actuator, and then I'm gonna push it in, and I'm gonna align all the screws. Okay, and once it's aligned, you need to push these screws in. So let's try and do that now. Yeah, and I think if we had the automatic equipment, it would be really helpful here.
Yeah, you want me to bring?
Yeah, it would be like helpful with the rest of the assembly as well. So pick up anyone that's like free throughout the day. Okay, so I'm trying to push all the screws in there, and we are gonna check if the motor is able to rotate, and as you can see, it's aligned in there. And now we are gonna grab an L key and we are gonna tighten these screws. Let me grab the L key in a second. So I have grabbed this one, and this is a bigger size. So this must be the right size. So we are gonna tighten everything together now. Yeah. We're gonna use an automatic equipment in a second, and that's gonna be much faster when especially because we have to tighten, and we have to tighten and open a lot of actuators, so doing this manually it wastes a lot of time, so we're gonna use an automatic screw tool. Okay, so we have that now. Let me prepare that. Yeah, so I think it's gonna be this. No? Yep, so I'm gonna be using this tool. This is not the right one. This is like broken. It only rotates in single direction.
Not in the other direction.
Yeah, it does not rotate in the other direction. Bring in another one. So meanwhile, I am gonna still try and do it manually, but we do have some other of these laying around, and we're gonna bring in the one that works. Yeah, so these screws, the 8 screws I have attached around this ring, they barely make their way to the opposite side, and you have to press this whole assembly together to get them on the other end. So as you can see over here, there's a bit of play with the 3D printed parts, and when you are tightening these screws, you need to push everything together, and you need to make sure the screws, they make their way to the brass inserts on the other end. Yep, so that's what we're trying to do here. We do not have another one. It's gone. It's gone. So someone has taken it. But what about the one with the wire?
Which one with the wire?
I'm gonna have a look. Yeah, because we had multiple of those. You can try to tighten these screws, but you really have to push everything together, and it's a bit of a struggle. So
Yeah, take a look, see if we're able to find. While the search is going on for an automatic machine that can tighten these screws, I'm gonna just try pushing these manually if I can. You really have to put in force to try to make them fit in, and I think it's not even grabbing hold of the hex insert on the other part. So let me confirm from here. Not even here as well. So like they're all of them are pretty loose. It's as if they are completely loose inside of the 3D printed parts. Okay, seems like we are able to find an automatic machine, which is gonna save us a lot of time. Let's try to bring that in.
So how long did I set this goal for? It's like almost about to end. That's strange, but we're gonna reset this once it ends.
Okay. Yeah, there's also one more thing we need to be a bit careful of. I think we might wanna change this.
This one.
Yeah, take off the glue just from the top side, and
Okay, let me heat up the glue gun.
Maybe just a little bit.
Yeah,
I'll
but
try
we
to
can
do-
tighten everything meanwhile.
Yeah.
Let's try and do that with the plastic welding soldering iron that we have.
Okay, that was pretty easy. So this is a very small magnet, if you can see over here. So it's off. By the way, when I was putting in the plastic, once you get a hang of it, you can do really precise
Yep, that's what we're gonna try to do.
layering.
So I have
around
turned
it, yeah.
this plastic hot glue gun on. So let's just put it to a side where it's not like dangerous, and then I'm
Yeah,
gonna
let's just put it over there on that side.
okay.
I'll put in something below it. You can tighten the screws in the meantime. And
Yep,
then we can-
that's what I'm trying to do. Just a second, give me a second. Yep, so it's I don't think the analytics they tell you this, but it's gonna be kind of difficult to gauge if these the views that are converting, if they're the new views or if they're like existing subscribers.
Yeah.
So I think the machine is live, the automatic one, and let me tighten the screws. Be careful with the hot glue gun down below, and move it a bit away from the heater as well. So guys, we have this thing ready, and it's really powerful, and it's really easy to break the 3D printed parts using this. But this is the best option we've got, and it saves you a lot of time instead of manually screwing and unscrewing everything. If you have any sort of small hardware shop inside your house, or if you have a small lab, or if you have worked on any hardware or robotics projects in the past, you do know how much time you tend to waste while manually fastening and removing screws from different parts. So that's why it's a really good idea to have one of these lying around. It saves you a lot of time. So yeah, I think I'm gonna have to push it and try to fasten it at the same time, because I don't think the screws are making their way to the opposite side.
Yeah, I don't think so either.
Okay, one of them just made its way there. So you really have to push these screws. You have to put a lot of weight behind this. Yeah, and even then, yeah, so this brass insert, as you can see, it's slightly pushed out of the body, so that's why the screw is not making its way over there. So we're gonna try to fasten as many as we can on this body.
Yeah, the rest of them we're gonna heat up the soldering iron, and then we're gonna insert the brass.
Nope, it's also not going at all. Let's try this one. Yep, so this one went in. This one I think also made its way down there. Let's go ahead with this one. Okay, so yeah, manually doing it would have been such pain trying to do it manually. Yep, it's not going in there,
Yeah, so
and it's really hot as well because of all the effort.
so I think we need to heat up a soldering iron and push in the brass insert a little bit more.
Yeah, I don't know what exactly what the issue is, but these screws, they seem to be like way off in terms of size. So let's double check the size of these screws. We're gonna double check the size of these screws because it shouldn't be this difficult to like push it in there. And let's compare them with these. They are slightly
Compare with
longer.
these ones.
So this is a bit longer. So we have some imposters in here. Nope. Nope, most of them were smaller.
Yeah, we have a lot of imposter tools everywhere in our lab, and our lab is a mess right now.
Yep, I'm pretty sure this one is gonna make its way through, but it's slightly bigger in size in terms of like being M3X60, but the head is different, so I don't want to attach a different head screw on this unit, on this module. So let's try and see if there's a size difference going on over here with these screws, because they all claim that they're 60 mm, but most of them are not 60. Imagine if we only had like 55 M3X55 screws, we wouldn't be able to put anything together.
Yeah. Wait, let's try pushing the brass insert with the soldering iron. Let me connect one.
It's still not gonna work though. Like,
Why?
how much do you have to push it in there to?
Like as much as we can push it quite far in there. Take it out.
So I'm gonna remove all the screws now.
So
This one is perfect.
unexpected lags in the project. So,
This one is perfect.
for a second, I am removing the hot glue gun.
No, I mean if it's hot, you can first attach the magnet.
Okay.
Just use it before like removing everything.
I think it is pretty hot at this point.
Yeah, so I'm gonna hand it over to you, and you can attach the magnet
Okay.
in there.
Leave it over here.
Let me try and grab it using plier. Okay, so we are gonna attach a magnet over here because we need to have that magnet on and this encoder in the right position before proceeding with the assembly. If I had the option to share the display on the live stream, I would play the Joe Biden teaches you how to paint your 3D prints video that I just uploaded. Maybe no, yeah, we cannot do it on an external screen right now. But yeah, these small features we need to add over time to our live streams, especially the display sharing option, and then definitely multiple camera angles. Because right now you don't know what's happening on this computer and the main computer, and also I'm also gonna be attaching a camera on the exterior of the lab to just kind of show how the weather looks, how the ocean looks, because our lab is right next to an ocean. So we need to add these small things over time. I think we can just have a USB hub and attach multiple USB cameras to it. That's the way I'm gonna go about it. And if you guys know any small cameras with USB that attach to computers through USB, check this. I think it's okay. Try moving it. Yeah, I mean it's gonna rotate, of course. It's gonna rotate, but try moving the magnet. No, I'm gonna have we're gonna let the hot glue sit for a while. Otherwise, it's definitely gonna move. Yeah, so if you guys know any cameras that are really good quality and small in size, and that can get attached to computer via USB hub, we need multiple of those cameras in this setup. I'm gonna be looking for those cameras.
So I'm gonna remove
remove the hot glue gun and attach the soldering iron now. So what we're gonna try and do here is on the bottom side over here, I'm gonna push all these brass inserts way in the design, so the M3X60 screws, they can latch onto these brass inserts when inserted from the opposite side. Right now we tried, but they're not making their way through on the other side. So yeah, if we are able to push out any screws, we were going ahead and doing that. So let me try and remove some more. Yeah, this one is set in there, this one too, this one as well. Yeah, so we need to remove all the remaining ones. So yeah, they're kind of stuck in there, so I'm gonna have to use the 3D print is done. So we're gonna show what we just 3D printed here in a second. So these screws over here, they're just refusing to come out, so I think I'm gonna try and push these while the screws are attached to the other end. They're not touching the brass inserts, and they're not in contact anyway, so I'm gonna try and push the brass inserts from the other end. Meanwhile, while the soldering iron gets hot, we have finished the 3D print, and yeah, this is the 3D print we were making, and we are gonna try and clean it up. Yeah, we have to remove a couple of supports from here. Okay, so yeah, we do have some precise supports over here that we need to remove, but this, guys, if someone in the chat can guess whose mask this is. I'm gonna reveal in 5 seconds. 4, 3, 2. This is Robin's mask, and if you guys have seen Marvel and DC, and if you guys are fans of superheroes, this is like a really classic DC superhero that's always with Batman, and there are multiple Robins, and of course there are multiple comic books for all of those different Robins as well. But this is a Robin mask, and I'm gonna paint it. First up, we're gonna have to do a lot of sanding on this mask, because this is how the 3D printed part looks right out of the printer. As you can see, there are some rough edges. It's not perfect, it's not smooth, and if you really zoom in there, you can even see the layer lines. So the first step with these 3D prints, if you are making action figures or any sort of cosplay props, the first step is to really sand them and get them smooth. So you need really smooth finish before you can start painting them. And then you also need to apply putty, and there are a lot of steps for that. I might make a entire video on that sometime, but if there are some really rough edges that you can't get to smoothen out by using sandpaper or anything like that, then you do need to use putty on these models as well. And I think there are spray putties as well, but they're a bit expensive, and they're easier to use, but they run out pretty quickly.
Yeah, spray putties are pretty pretty crazy. I've never heard about that.
Yeah, there are like they're just like spray paints. Can I grab water from there? Yeah. So they're just like spray paints, but they are expensive compared to the painting putty that you make yourself, and they do tend to run out really fast. So I have never used one before, the spray one.
That's pretty interesting.
But I have used the regular putty, the one you brush on top of surfaces and you give it a couple of hours to dry down. It works like magic. It really smooths out your 3D print, and after that you can even make your depending upon your painting skills and what paint you're using after using putty and after using sandpaper, you can even get your 3D prints to look like metals. It's yeah, so it's a whole artistic feel of its own in terms of finishing 3D prints.
Yeah, so all of the supports have been removed. Just this small part from here. It's bugging a little bit.
Yep, so removing the supports from 3D printed parts, it's also like it also requires a bit of learning through the process. So I think the soldering iron is hot, and now I'm gonna try and push these brass inserts way in there in the design.
Yeah, as much as you can.
Okay, so they are really being pushed in there now. Yep, so I am having some difficulty pushing these ones in there, the ones that have screws right next to them as expected. So I'm gonna try and push them in without coming in contact with the screws on the other end, but as expected it was a bit difficult with the screw still in there. Okay, so I think we can we're just gonna let it cool for a second, and then we can try pushing the screws from the other side and checking if they make their way through the entire design and if they latch on to the brass inserts on the other side.
Yeah, in the meantime, the supports have been removed from this one, this 3D printed part, and as you can see it looks like this. Overall it's a pretty good quality print, but however obviously the next step is sanding, and sanding is gonna make a huge difference to the overall look of this. So even if we do have a little bit of defects or print lines showing in some parts at the bottom side of the mask, sanding is gonna make a huge difference, and that's gonna be the next step. So in the Biden video, the one that you shared, you were using a tool and there was a sandpaper on top of it.
It was just like double. I just attached
double-sided tape with a part. I think
yeah.
that was a really good idea, because with hand it gets really
Yeah,
tough.
man, like I have sanded so many 3D printed parts in my life, like so many. After a while you like kind of lose it, and you try to find any method to like make it easier. So in the latest short video I just published, it seems like I'm using some sort of sanding tool, but it's not a sanding tool. It's just like a sandpaper attached on top of a plastic body by using double-sided tape, and it tends to help a bit. Yeah, this mask looks really cool, and size wise also I think it's perfect.
Yeah. It's gonna look really cool in black color as well.
Yeah.
Like right now it's white.
So guys, now all the screws are sitting in there perfectly now. Everything is perfect now in terms of assembly. So yeah, attaching those pushing those brass inserts in there, it really helps with the design. So this is what the attached actuator looks like, and as you can see, the screws we inserted from this side, they have latched onto the brass inserts on the opposite side. Time to move on to the next step. After that, do we have like we have an M6 C12 actuator right after this. So
I wonder what's the flexibility of this mask.
I mean, it's gonna be flexible, but no one's gonna try to flex it to the point where it's gonna break, of course.
Yeah. But in terms of just the ergonomics side to it, so comfort in wearing for a very long time, because right now
it's pretty lightweight.
Yeah, it's pretty lightweight, but these parts are a bit sharp right now, because obviously it's not been sanded. But right now it does feel a little.
Okay, so we need to make the hip roll now, and where's the part for it? If I'm able to find the part. Yep. Yeah, I think it's this part. So the next up we need to grab this 3D printed part over here, and we need to align these holes like so, and then we need to use screws to tighten these two together. So I think for these we need M3X20 screws.
Yeah.
And I think we ordered M3X20 from Amazon, no?
Did they arrive?
Yeah, I think so. If they should have arrived.
I saw some parts over here. I put some screws over here. If you can check. Here, this one. Or this is a new pack.
Wow.
These are M3X20.
Yep. So yeah, we always we always as it turns out, we're almost like it's a razor sharp close in terms of deadlines.
I'm gonna close this now.
Yeah,
Take it off.
yeah, just turn it off. But I think we will have to use it for all the other actuators as well.
We'll just plug it in again. But
I
for
mean,
now it's
no, I think we should keep it attached, and we can just put
Okay.
it on that table to a side. So where is the drawer for the M3X20? I'm gonna find it, and then we're gonna bring it out over here. So I am looking for M3X20 screw.
maybe just because this is a separate.
Yeah,
part.
I think it's these ones. So these are M3X20. So we do need a new drawer for these ones. We don't want to get the magnets attached over here. Let me remove them during the live stream. I think a lot of viewers that are tuning in at this time of the day are probably from India or Pakistan, because it's nighttime, roughly nighttime on the western areas,
Yep.
western part of the globe.
Yeah. But even like people do watch YouTube during nighttime as well.
Yeah.
Like, there's all sorts of people that stay up all night.
I
or
mean, but
sleep
usually,
early.
mostly they're kids. I don't think any.
Yeah.
Yeah, there are almost no grown-ups at nighttime watching YouTube, because grown-ups have responsibilities.
Yeah.
Any kids listening to this? Grown-ups have responsibilities. Normally, like during nighttime, almost all the viewership online is kids.
Yeah.
Just because they have the time, they can afford the time to
Yeah,
like be
our
online.
channel has pretty interesting stats in terms of the kids versus adults
Yeah.
who watch this. I think almost a majority of our audience is grown-up people.
Grown-up
right?
people, yeah. Yep. We are trying to push more kid-friendly content out there. I mean, it's not kid-friendly in terms of like poems or stuff like that, but a lot of non-technical stuff, more towards the Ali, can I grab the vernier caliper? Yeah, more geared towards that entertainment side of things, but it's gonna be still technical in terms of it being robotics and stuff like that. But there are not gonna be like explanations, crazy explanations or anything like that.
Or if we can make explanations a bit more entertaining or in a cool way,
Yeah.
in a storytelling or cool way.
Yeah, I think so. Yeah, so these are not the right size.
Which ones?
These are M3X12. So yeah, I think I'm just gonna grab another one, and we do have a lot of empty.
How about we just attach these?
What? We do need a place for these. Otherwise, they always end up these packs. They always end up getting lost. So we need to keep track of how many of these we are using, because once the other order arrives, we will have to refill everything in our lab.
Do you want to put a label on them with this?
Yep. Yep. Yeah. So wow. I never thought of this. Using masking tape, we can label all the items here in our drawer. So yeah, this is a bit helpful. So I'm gonna label it. If I can grab pen. So these are M3X20, and for these screws, where are they not mentioned? On the bill of materials. So these are not mentioned on the bill of materials for this robot, and if you plan on building these if you plan on building this robot, you need to have M3X20 ones lying around in your lab. We needed a lot of these for the upper part of the robot's body, and I think they're gonna be used here now. Yeah, so let's move on with the assembly. So what we are gonna do is we are gonna grab this part, and I'm gonna be putting these screws in there. So once again, these are M3X20. And we need to put 6 of them in there, and 2 more. We need to remove some supports, so I'm going to use this tool. So this is how you remove supports from 3D printed parts. So there are a lot of specialized tools to remove supports from 3D printed parts, tools like this, and you can get them from really cheap from Temu or any Chinese website.
Yeah, these tools, I don't know, there's most likely markets here in Japan or these countries, industrial areas or specific markets where you can get these tools for pretty cheap. But in big stores, in retail or like commercial stores here in Japan, these tools are really expensive.
Yep.
Way more expensive as compared to like China or Pakistan or India, these countries. Extremely expensive. So if you're setting up a whole lab, these costs really do add up.
So once we have those screws in there, we need to align these over here, and then we are simply gonna tighten all the screws. And to do that, I think we are gonna use this thing, and I'm gonna change the module for it. Here, can you check, Ali, what's the next actuator we need to put in this part?
It's gonna
It's 11 upper leg ZL. 11
Yeah.
upper leg ZL.
it's gonna be here or on that table.
Yep. So this part has been attached over here,
And it's rotating perfectly. So that's good.
and it's really difficult to rotate it as well. It's like it requires a bit of force. Okay, so once we are done with this one, we are gonna bring in the next part, which is lower upper leg ZL. Where is the 11 upper ZL? So it's this one.
Can you check the magnet? Okay, the magnet must be correct with this one.
Okay, so this is the next one we need to attach, and this is the other unit for that actuator, and we're gonna separate these two, and we are gonna put them in here. Okay, but before doing that, Ali, I think we need to attach the encoder over here and then put everything
Yeah,
together.
and you know what I'm gonna do? I'm gonna separate out the motor to attach on this leg as well, because we have it ready, this one as well. So while we're at it, I'm just gonna attach that one as well.
This motor.
No, the one that comes over here.
Okay.
We do have that one as well, right?
I mean, I think we should just finish one leg.
Okay.
Because I want to get all the footage ready for the tutorial,
Okay.
so I can just edit it and upload it as a tutorial, and then we can just sprint the other leg off camera or something like that.
Alright. So,
So what I want you to do is, if you can
Okay, yeah.
use M2 screws to tighten this. Meanwhile, I'm gonna open this up on camera. Okay. So first up, where is your screwdriver? Where's the screwdriver? The small one. It's gonna over there, the red, in the red box. And then in terms of the M2 screws, these are the M2 screws, and in terms of
the washers.
the washers, I think some of these washers will work.
There were some which work, but I think these are all the big ones now. Maybe I'll try it. Let's see.
Okay. We have some washers in here as well, but they also look really big.
Yep. These are all big washers.
Oops.
I really wish I could clean the lab right now, but it's just that.
Yep, I think we're gonna go on a cleaning spree after this live stream. Yeah, so there are, I can see some smaller washers in here. Okay, so the next, so to attach to attach the next encoder, we need to disassemble it. So for this actuator, I am disassembling this over here, and you can separate everything out because we need to push it in there. And then I am gonna remove this. And let's put everything down below like this. Yep, so everything is ready. Now we're gonna put that in there. Once the encoders are attached, we are gonna put it in there.
Yeah, you can watch this video on that screen as well.
Yeah. I don't have like 2 of these videos running in the tutorial after that, because that one is in the view. So it's gonna be like a video inside a video,
Oh.
a tutorial inside the tutorial kind of thing.
So someone else dropped a like as well. Thank you very much for the support.
Yep, it was probably Reg. Hey Reg. Hi guys, you were earlier today. Yep, it's close to 3 p.m. over here. And it's raining cats and dogs outside, so we can't do anything outside. So we just figured we can put together the legs of the robot, and we can do a live stream while we're at it.
Yeah, and we had some parts being 3D printed as well.
Yep, so Reg, we just 3D printed this. We're just testing how this turns out and how well we're able to finish this.
Finish paint into a
Yeah.
well-made product.
So this is like a cosplay prop. It's a Robin mask, and it's pretty famous in Comic Cons and other cosplay events. A lot of people geek over this stuff. I might be one of them. Who knows? But yeah, so a lot of we have been testing more specifically anime props and items, but this is the first one we made in terms of Marvel or DC, and it took about 1 hour to print on our Bamboo Labs printer.
Yeah, now we're gonna just sand it, paint it, finish it, and just test the product quality
Yep, so
to get an idea about the quality of finish that we can
yep,
get.
so and I'll upload a short video on this as well. So I'm gonna make a video on the process of sanding it, and then if there are some ridges that are not fixed during the sanding process, we do use putty for these 3D printed parts, and using putty and sanding it again after that, it makes these 3D prints look really beautiful.
Yeah.
And I was telling earlier in the live stream, you can even make this look like metals, actual metals, if your sanding and everything is really spot on. So I'm gonna make a short reel for this for my YouTube.
To paint a 3D, how to create a really good finish with paint on 3D printed material, which is a very famous topic in and of itself on YouTube. It's a very highly searched and a good
Yep.
topic.
And if our Joe Biden short does well, I think we're gonna have Trump explain the next 3D print
Yeah.
in the video. Who knows? So yeah, so we have attached this over here to the groin section of the robot, and the next step, once this is done, is we are gonna pick up this part and we are gonna push this in here. So I'm gonna push it in here, and I am gonna place this bearing on the top section over here. So the train is passing by. It I think it messed up the sound of my recording. Let me play this over here. Okay, once the bearing is in there, we are gonna grab this ring and I'm gonna align these holes and I'm gonna put it on there like so. I made something like this before. I painted the mask in chrome. The result was very nice for a mask. Yep, the chrome finish looks really sick on 3D prints. I've never tried that finish before. Any sort of metallic looking finish, I've never tried it before. But yeah, I'm really excited to try it on 3D printed part.
Yeah. Yep. There's most likely gonna be a tutorial for this very soon on the channel. As
Generally, how good your finish ends up looking, it comes down to how much sanding you've done. So if you're saying, Reg, that your finish it turned out really nice, I can imagine you sitting in the sunlight for hours on end, just hours on end, just sanding it away. It usually comes down to this.
Yeah, but like, I'm really excited for the paint on this.
And once we have this unit over here attached, we are gonna insert another bearing on the bottom side over here, and we are gonna snug it in, and we are gonna make sure everything is nice. And after that, I'm gonna pick up another ring and I am gonna align these holes and I'm gonna push it in over here. So we have to make sure all the holes are perfectly aligned, and then I'm gonna try. Yep, it gets really difficult to rotate it once you've attached it. So I'm gonna try and push this in there to try to align everything. Yep, so now these holes are aligned. So next up, I think I'm gonna rotate it towards the outside, and we are gonna grab the next actuator and we are gonna align it and attach it like so over here. But before doing that, we are gonna grab M3X60 screws and we are gonna push these in the holes over here.
Yeah, so just to make sure, do we want to put the hex inserts
we
in?
do.
Okay,
We do.
I'll do that quickly and just.
So I'm gonna be putting these in there. Okay, so yeah, these holes, they're not perfectly aligned.
If I replicate the Berkeley Humanoid, I will make it in black with filament metal filled composite to have the more solid part. If I replicate the Berkeley Humanoid, I will make it in black with filament metal filled composite to have the more solid part. Yeah, so Reg, I don't know if you have already joined the Berkeley Humanoid Light Discord server or not, but many guys in there have 3D printed the entire actuator, the entire robot in black, and it
Yeah.
looks pretty different.
Yep, and I would say it looks much better.
Yeah.
Yeah, white and black, they're both like timeless colors.
Yeah, they're both
they both
timeless.
look really good.
Yeah, but
But I
but-
don't know about reinforcement or any specific sort of materials in
Yeah.
terms of 3D printing, but I don't know if people are trying that in the Discord server, but definitely different colors.
but like filament metal filled composite, you'll be the first one to do it.
Yeah, I think no one has done
Yeah,
that.
not only have I not seen anyone else do it, but I also think no one has done it in general. So like, if you're gonna if you do that, you're gonna be the first one to do it. And I also think in general people will think when they look at that robot, they'll think it's made of aluminum or some metal part. So yeah, that's
I
a
don't
pretty
know.
interesting idea.
Yeah, finishing wise, I don't know if we're ever gonna try that, but maybe we can make a entire body for the robot using 3D print, like all the exterior body and exterior shell, and paint that after like sanding and cleaning the entire thing.
Yeah.
That would look really cool.
Yeah, so like it's maybe an added, I don't know,
In terms of marketing and stuff like
yeah,
that.
1 week of sanding and painting all of the parts. Maybe
It will
If you
look
do it-
really good for marketing
and like
purposes.
one week, if someone does it really fast, then 1 week. So maybe full-time person doing it every single day.
Yep, so.
I think it will take maybe 1 week or even a bit more than 1 week, because the 3D printed parts, there are a lot of parts. 22 actuators. All of those actuators have individual components and parts, as well as there's parts outside of the actuator as well. It's an expensive filament, but more durable and resist to shock if the bot falls. Yeah, for sure, it will be more durable as compared to just the simple PLA.
Yep. I think everyone goes for PLA,
Yeah.
and very few people go for PETG or ABS parts.
Yeah, but it's definitely gonna be
The
different
community overall is so small that I don't think anyone has thought beyond that.
yeah. In their entire Discord server, when I joined, which was just a couple of days ago, it's not been long. There's only like 200 and something people, and even from them, there's only maybe like 5 or 6 people that communicate very
How much have you
often.
pushed these in there?
A lot.
Yeah,
A lot.
you don't need to like overdo it. Just a little bit
Okay.
in there is good.
I might have overdone a little bit, but okay.
Yeah, just a little bit in there is good enough.
Yeah. Okay, let them cool down a little bit. Yeah, so in their entire Discord server, there's only like 200 and something people, and even from them, there's only 5 or 10 people that are actively communicating and sharing their updates. It's a really small community, and most of them are just using PLA. I know 1 or 2 guys that are using black color filament. They're building black color actuator and robot parts, and they looked really cool, to be honest. But no one, of course, has thought about metal filled composite. No one. And if you end up doing it, you're gonna be the first one to do it.
Okay, so once all these screws are in there, what we're gonna do is we are gonna align these two parts of the actuators, and we are gonna push them in, and we're gonna fasten them using these screws.
Okay, so Reg says, I don't know the URL for the group. Let me guide you step by step. Let me find the URL, and
We can put it in the chat.
It's not a URL, it's a barcode only.
Okay, okay.
It's a barcode invite, but I'm gonna guide.
We got a new chatter. Chaitana Vishmika. Sorry if I'm not pronouncing your name right, but we now have 2 avatars in the live stream, which is like so cool to see. Yeah, so in total we have 3 avatars now. Hey Chetna, how are you doing? Where are you from? I'm assuming it will be somewhere in the South Asian part, probably. But correct me if I'm wrong. Yeah, so I think generally during this time of the day, more people are active.
Yeah, it could be.
Yeah, so more of our subscribers are in this time zone. So I think we're gonna try and do a few more of these live streams during this time as well to see how it pans out. Where are the other hex stands?
Yeah, so Chetna has asked a question. What is the name of this motor? So I'm gonna show you the motors.
Yeah, it's a MAD Components BLDC motor.
Yeah, it's a MAD Components BLDC motor. We have 2 of them. We have the MAD 5010 110 kV, and we have a M6 C12 as well. Just a moment, I'm gonna bring that as well.
From Sri Lanka. Let's go. We have some Sri Lankan friends working on another project outside of our lab.
From Canada here, it's 2-3 a.m. Oh my god. It's so late over there. So MAD 5010, this is the smaller motor for the small actuators that we're building, and the M6C12 BLDC motor. This one has a slightly bigger size motor. This one, it's actually this one. This is the M6C12 actuator motor, and this is the 5010. You can see the size difference roughly. So yeah, some of the robot parts use this one, some of the robot parts use this one. So these are the 2 motors we're using.
Reg is like deep in the like what do you call like the gasoline. What band was that? Like I don't know. Like Reg is struggling with insomnia or something. So earlier, Reg, we were talking about how most people that are active during the late night time, most of the time they're gonna be young people or kids or teenagers, because they can afford the time to join live streams, hop around on YouTube, Twitch, and these platforms. So if there were any active chatters during nighttime from the US side or the Western side, our assumption was they were gonna be like kids who had a lot of free time. But it's rare to see people, grown-up people, surfing the web during these late hours of night. Reg, what's the torque for this motor?
Yeah, so the torque for M6C12 actuator, I haven't really looked in detail the specifications, but for the MC612 actuator, I think it was somewhere around 3 Newton meters, maximum torque of 3 Newton meters somewhere. I haven't looked in detail though. By the way, Reg, I also wanted to share with you the link to find the Discord community. So if you go to Berkeley Humanoid Light documentation, there's a lot of different URLs that you can go to. You can go to their documentation or video or paper. You want to click on the website. Once you click on the website, you'll be routed to their official website. From there, you can scroll all the way down, and here they have a barcode for the Discord community. This is from where I joined the Discord community. It's a pretty small and niche community. It's only 200 and something people in there. It's a very tightly knit group.
Can I grab the hex tools? Chetana says, I will hope to make a humanoid robot. Let's go 100%. Everyone including us that are working on this robot, and everyone in this live stream and the chat plans on building this humanoid robot someday. So Reg probably also wants to build this humanoid robot. And Chetana, if you plan on working on this anytime, I would love to see the progress. I would love to follow up on that.
Yeah, there's many open source robots. There's this Berkeley Humanoid Light that you can build. There's K-Bot as well from the K-Scale Labs that you can build. There's other these are the two good ones. Other ones, at least from what I have seen, are not very decent looking in terms of their just general looks. But yeah, there's many options you can go for. I think this is easily the cheapest one that you can build. Berkeley Humanoid Light, it's under $5,000 just for the parts. I think so. I would like to create exoskeleton with this kind of motor.
With this kind of motor, I think I have not looked into it, but there are. I think you're gonna need really high torque motors for that. Some BLDC motors do offer a lot of torque, and I doubt anyone uses stepper motors for exoskeleton or anything like that, but there might be some options on that end as well. But I don't know professionally if these motors can be used to build exoskeleton. You need a
Reg, there's also one other open source project which I'm not sure if you're aware of or not. It's this AR4. It's like a SCARA. It's a 6 degree of freedom robotic arm, and it's also completely open source, and it's extremely good quality. It's a while back I wanted to build this robotic arm, sort of a SCARA arm, and I looked into this a little bit. It's fully open source. It's pretty good quality, and the code can be customized as well. So if a while back when we had discussion about medical field and robotics, I think this could be a very good. Already there are a lot of people and companies that are building very cool applications with this. The owner, the builder of this robot, he shows them on his channel as well how people are using this in very interesting niche applications in industry. But yeah, this could also be a really good product with an end effector that's specialized for medical use or any particular niche use that you want to use it for.
Chaitanya, if you are still in the live stream, I would like, if you're comfortable with sharing, I would like to know what kind of projects you work on. If you are interested in electronics or robotics, if you work on them as a hobby, or if you work on them professionally.
Yeah. Yes, I think I need to do some calculation to find out the right motor. Yes, calculation will 100% be needed. At the end of the day, you have to make sure the torque that.
And I think definitely you need to check out about hydraulics as well. Like I said, because exoskeleton, in my opinion, I haven't looked as much into it, but I think it will. A lot more goes into mechanical leverage and hydraulics and stuff like that. But of course, motors are a big part of it as well. If they use motors in there.
Yeah, I saw this arm and it's cheap. I think $200 to create it. Yep, it was pretty cheap. I think the if you want to save time, the owner of this is also selling the 3D CAD designs. I think they're not entirely free, but he was selling the exact STL files, and it was, I don't know exactly, maybe $100. I don't. It was a while back when I looked at it. But yeah, the exact STL files are available. You can grab them. You can assemble them in your own Fusion or SolidWorks software, and from there, yeah, you can go ahead and build them.
Yep,
build the arm.
Yeah, the tides have turned this time. This time we are doing the live stream at 3 p.m. in the morning. Reg is like, it's like 2 for him.
Yeah.
And every other day, Reg, we used to push the live stream up to like 5 a.m., 6 a.m. in the morning. Sometimes we ended around 4 a.m., 5 a.m., but we were generally working even after that. But it's so refreshing to see other people who are working on these kinds of projects be up during this time of the night, potentially working on some cool stuff as well. I think we're gonna have to attach this using a double-sided tape. But yeah, this one. Okay, so this part is ready, and now we are able to rotate this actuator, and it's really smooth. Like, it's almost not making any noise.
Yeah, the exoskeleton I talk about, it's more a leg assistance to help walk faster or climb. Okay, got it.
Got it.
So it's just it's an assistance sort of a.
Yep. So yeah, it kind of falls in the same category as those prosthetics we were talking about.
Yeah.
Chaitanya asks, "Where are you from?" We're in Tokyo right now, but we're from Pakistan originally.
Yeah. So originally we are from Pakistan. We had a small sort of robotics or industrial product sort of a lab there as well. We used to work on these stuff back there as well. But currently we are in Tokyo. We're in Japan currently, and we have some friends from Sri Lanka here as well. In fact, some really close friends. And back in Pakistan, there's only like Pakistanis. There's not a lot of foreigners there. But ever since coming to Japan, we've met a lot of foreigners, Indians, US, Canadians, as well as Sri Lankans. There's a lot of Sri Lankans here, and we have some good friends from Sri Lanka here. Overall, the Indian, Pakistani, Sri Lankan, and Bangladeshi, these communities are really close here in Japan. I think that would be the case pretty much anywhere else in the world as well. These communities really tend to get together. So here in Japan, these communities usually know each other. I know many friends that are Sri Lankan, as well as Indian, from Bangladesh as well.
No way. Damn. Is this our first
That's our first one.
that's our
Yes.
very first super chat. Thank you so much, Reg. Damn, man, you really made our day. Thank you so much for that.
Unbelievable.
Unbelievable, man. Yeah, thank you for making our day, and thank you for always being here. And we're gonna, thank you for like, yeah, man, I'm really speechless at the moment. Yeah, so Chetana, we are gonna be working on these projects, and that's pay the lunch. Yeah, no, it's like way more than lunch, man. Like, this is the first. The channel is not monetized yet, so this is the first financial. Even the goal of it is not financial in any sense. We're just gonna be documenting whatever we're gonna be doing in the future as well on this channel. But this is the first time someone has supported the channel in this way. So thank you so much for this, Reg, once again.
Reg.
I really appreciate it. And Reg, you know where I'm gonna spend all of this money on? So this is gonna pay for all the coffees I'm gonna be consuming during the next live stream. So I have 3 coffee cups that I can grab right now in my vicinity, and this is the fuel that keeps these projects going, at least in my case. So yeah, these are gonna be going towards the coffee.
Yeah. Once again, thank you very much, man. It's like it's pretty hard to describe how that makes you feel, but yeah, thank you very much. And thank you for the support, and thank you for always showing up. So, Chetana says, I already made some electronic projects. I uploaded videos to my YouTube channel. Yeah, if you look at our channel as well, we have built some IoT microcontroller videos and uploaded tutorials as well. I would love to know about your channel. I think if I can look
Yeah,
from there,
we can click on his channel and
Yeah.
view his channel. Yeah, but
Yes.
I would love to see after this live stream what sort of
Hey,
projects.
cool. That will help you. That will keep you awake at night to work. Yeah, 100%.
Yeah. So yeah, we're like already night owls at this point, but
Bro, that's unbelievable.
yeah. So Chetana, we are gonna check your channel as well, and if you what kind. Yeah, we don't want to get a we
Not
don't want to
a-
get a copyright strike. Not on this live stream.
No, not on this one.
Yeah, so okay, so yeah, you have played around a bunch with microcontrollers. I can see how to make Arduino robot car, remote control car. Oh, that's cool. Yeah, so pretty much you're working on these projects all the time.
Yeah, and his most popular video 6.6K views. It's a short, I think, a short video. Then 4.2K, 3.4K. Okay. No.
No,
not
we
at
don't
all.
want. Yeah, we don't want.
We don't want to do that. Yeah, Chetana, we've checked your channel and it's a pretty good channel. You have a lot of tutorials.
Yeah,
on
and
there.
and the
Yeah.
next step for you as well, Chetana, is the humanoid robot. It gotta be done. It's anyone like who's following this live stream, they must really want to like, cause in terms of like the when compared to other live streams on the internet, it's not as flashy or entertaining or anything like that. It's just pure uh, technical stuff. So yeah, people who are following these live streams, they're definitely gonna be working on these kinds of projects.
Yeah. Chetana, your channel is already pretty good, really good. I don't think I can add more comments to it. You're already doing pretty great, pretty amazing. In all honesty, there's just one slight suggestion. It's something that even I have just come to learn recently, and it's about SEO. If you can crack the right keywords, I think you can at least even with the number of videos that you have currently right now, it will 10x or 20x your channel.
It's just a thing I really want to talk it for the tutorial.
Okay.
Yeah, so I'm gonna be making a summarized video for these as well, so that's why I'm gonna be clipping these from this live stream. So once the next step is to grab this 3D printed part, and we are gonna align these screws over here, and we are gonna fasten them. Okay, now you can continue. Sorry.
Okay. Yeah, so even I have, for a very large portion of my YouTube career, I have really underestimated the impact of keywords and SEO. It's a night and day difference. It's the difference between like earth and the sky. It's that huge of a difference. One video which you put out there on the YouTube with the right keywords and SEO, it keeps performing for years on end. It keeps bringing you more and more views for years on end. So like that's something that I will heavily start focusing on in the next couple of days. I have never focused on it before, but that's just something that I recently learned, and it really opened up my eyes towards this aspect. Other than that, your channel is pretty amazing. Keep up the good work. You're doing really amazing things.
Yeah, in terms of quality, the next live streams, there's this really cool feature in the stream avatars where whenever someone types in the chats, and we have somewhat of an active chat these days, but whenever someone types in the chat, the stream avatars, they are also supposed to talk it like in a really cute sound.
Yeah, Chetna says, goodbye, bro. Now I have studies, works. See you. Hey, see you, man. Thank you so much for tuning in. And yeah, good luck with the studies and work. Give it your best. And yeah, thank you for tuning in. See you again. See you around.
See you, matane. Yep, so yeah, in terms of the stream avatars, we have to fix the issue with the sound, and then after that we do have to add multiple camera angles that we can switch between, and we also have to add the display. This display, so whatever we're recording, whatever software we're running, we're able to show that on live stream as well. So yeah. Chetna said love from Sri Lanka. Awesome, man. Talk to you. Take care. And yeah, these screws are, they're not like going in there. So they're like really stuck in there. I wish we had like a really big L key with a lot of mechanical leverage, but I'm gonna try and push these in there once again, but they're not like going in there for some weird reason.
Bring it in front of the camera a little bit. It's still not going in.
Yeah, it's not going in all the way. Why? Because it's supposed to be
3x20.
Yeah, 3x20 over here, but it's not going in. So, and it's also not coming out now, so we're kind of stuck in this limbo. Oh damn! Yeah, man. I got so excited with this last stream. I'm using the wrong tool head. I'm using the wrong tool head, man.
We also have 3 likes.
3 likes, I think, is the new record.
Yeah, it's also a new record.
It's also a new record. Damn. Yep, it's going in perfectly now. Those 3 likes fixed everything. Thank you so much to whoever dropped that 3rd like on our live stream. And if you wanna hop in the chat, if you wanna discuss anything about robotics, electronics, anime, whatever, you guys can ask us any question.
Yeah, and once again, Reg, thank you so much for the super chat. It's still very unbelievable.
Yeah, it's so surreal.
Yeah, like I would need to practice how to respond in a cool way once someone sends support in such a huge way, because it's really sort of you're sort of expecting something like this, but you're also sort of not expecting it.
Yeah,
it's a pretty strange thing.
Yep, and I honestly was not expecting to get a super chat anyway by like robotics or tech project.
Yeah,
I mean these kinds of things, they do tend to happen a lot with entertaining streams and stuff like that.
Yeah,
or if people, they really like their favorite political commentator and stuff like that.
yeah.
Okay, so the next actuator in line is the 12 upper leg XL, and let me find that one. Upper. Oh, bro, I set I fixed a goal for the live chat that we were gonna show the upper body.
Oh,
Yeah, I don't know if we'll have to like drag in the upper upper body in the frame now.
yeah. We can just drag it and show it over here.
Yeah, so
For
a small, yeah, a small segue towards showing the upper body and how much progress we have on that side. We are gonna push these things slightly to a side because the upper body is really huge, and we don't want it messing up the setup we've made. And promise is a promise, and here's the upper body. I'm trying not to drop it on the keyboard.
Yeah, it's not even fitting in entirely in the camera.
Yep,
yeah.
so this is the one arm. The robot
hello.
says hello, hi, konnichiwa. And yeah, all these actuators have been calibrated and they were working fine last time we tested. And we also have a circuit breaker over here because all these actuators they have a common power wire now, the common power and ground connection, and if it goes over 30 ampere it's gonna cut off. So we do have this attached over here as well. And I think we are gonna be done with the lower body in a day or two. Today there were 3 motor controllers that turned out faulty for some reason, or at least we couldn't get them to work, and today we are going to be receiving the new ones. And after that, I think probably by the end of the day we are going to finish the lower part of the robot's body, and after that we're going to put the entire thing together. Most probably the next live stream is going to be the entire robot put together, and I'm definitely gonna have a better camera setup compared to this for that. Definitely.
Yeah, because the body of the robot.
Yeah, the body is really huge, and we're also gonna be running some softwares, and we're gonna be testing that in the next live stream. So we're also gonna try and live stream the software or the computer screen as well.
Yeah, this live stream has been really crazy. We just randomly thought of putting it, starting the live stream during daytime today. First, there was a heron that showed up.
Yeah.
That was the very first thing. There was a heron that came out and sat really close to our lab.
Yeah, and the heron, he just said, "What's up, chatters?"
Yeah.
And I showed a video of the heron in the live stream, and then he just
flew off.
Yeah, he just flew off. Like he wasn't even like scared of us or anything. He just was in for the like live stream, and as soon as I recorded some video of him and placed the camera back on the table, he said, "All right,
Yeah.
see you, chat."
Yeah, he wanted to be a part of live stream. He wanted to say hi to the chat.
Okay, so now for the tutorial. Okay, once this part has been attached over here, we are gonna move on and we're gonna grab the next M6E12 actuator, and this is the other part, and we are gonna disassemble it and we're gonna put it in there over here. So I am gonna grab the screwdriver, and today also for the very first time we had three active avatars in the live stream.
Yeah. For the very first time.
And it tends to like compound in terms of how exciting it is to see multiple avatars walking around in the.
Yeah.
Okay, and I'm gonna push this out, and then I'm gonna remove this bearing for now, and we are gonna put this part, this gear assembly through here, and I'm gonna pass it through. And then I'm gonna grab this bearing and I'm gonna put it over here like so, and then I'm gonna grab this one ring and I am gonna place it over here. So we are gonna align everything, make sure these holes are aligned, and I'm gonna push it like so. If the holes are not aligned, you can use some sort of a thin tool to push through these holes and get everything aligned like this. So we're going 3 likes, 2 concurrent viewers, and 30 views strong so far, and 1 massive super chat in the live stream.
Yeah, and if you also take a look at the graph over here, this one is massive.
Yeah, the activity around here turned out to be crazy, and I think this is probably the time people are, I don't know, yeah. In terms of like the analytics for my YouTube channel, I've looked into it a bit, and the analytics are totally off. Because if we follow them, most people that have subscribed to my YouTube channel, most of them are active during the night time, which is contrary to the experience we've had so far.
Yeah.
So they do sneak in during the daytime as well. Okay, so it's somewhat aligned, but I'm still gonna go through, and I'm still gonna continue this. Okay, so once, yeah, it's kind of there's a kind of space between here that I'm sure when we put the screws over here and we tighten everything, it's gonna be removed. Then I'm gonna turn this unit and I'm gonna add a bearing over here like this, and then we're gonna grab the second ring and we are gonna align the holes over here and we are gonna push it. So let me double check the orientation of these holes. Yep. And let's push it together. Okay, that's done. Now we're gonna grab M3X60 screws and we are gonna push them through here one by one. So 1, 2, 3, and 3 more actuators to go, right? There's 6 in total. I think so. Yeah, there's 1 more M6 actuator that will go in this leg, and then there's 2 5010 actuators that will go to the ankle and the feet. Yep. And where? Here's the other module. Yep, it's gonna be really difficult to. Yeah, do you want me to push for even this one, the brass insert? Yep, 100%. Just go ahead with it. Pick it up. Okay. Is this the right one? 12 upper leg XL. 12 upper leg XL. Yep. So the lower part of the body, it takes M6C12 actuators first of all. So the first 3 actuators we have joined their M6C12 actuators. Yeah, Reg has asked. What kind of battery you will put in this robot? I think 48 volt, right? No,
you can
Reg,
show. You can.
It's gonna be
there. It is there in the front.
Yeah. Sorry. So it's gonna be how much? Yeah, it's gonna be this one, and it's 22.2 volt battery. Yeah, and the official documentation has recommended this. Yeah, the official documentation has recommended this battery, but so this is what's officially gonna go in this robot once everything is done. But on all of my projects, Reg, and all the projects I have built in the past. Take it off. Okay, just a second. Leave it on. Don't. Where's the plier? Here. And
It's-
don't throw it on the floor, otherwise it's gonna like okay.
it's
So
gotten all black.
yeah, we almost burned it. Yeah, it's like a, yeah, it's like a magma at this point. So we
Almost.
burned this hex insert, and it's really hot right now. So we don't even have any place to put it. It's gonna melt the plastic, or if we throw it on the floor, it's gonna melt in there as well. Because it's not like exactly metal or any sort of ceramic floor. What's kind of yeah, so Reg, I was talking about the battery. So this is an Ingo for 20-volt battery, and in all the projects I have built so far where high voltage or high power is required,
For all of the robotics.
yeah, for all the robotics projects, if like for example, let's say if I want to move the base of the robot, or if there's a really heavy load on the robot and we need to rotate the tires of the robot, I always use this battery. At least at the prototyping stage it has worked out perfectly in all the cases. So we have used this for stepper motors as well. NEMA, what was the NEMA 34, I think it was, like the one with the 8 Newton meter torque.
Yeah.
It's a really good stepper motor and it's really powerful. I think no, NEMA one, it has 12 Newton meter torque. Sorry, yeah, the NEMA motor we use with that, it has 12 Newton meter torque, and it also worked out really well with this battery. Multiple NEMA motors. So this is the battery we use to prototype test all of our robots, and after that, this is the one we were using to move the upper body of this robot as well. And after that, we're gonna be putting this battery in there for the robot. So where am I supposed to put this burning piece of magma? Yeah, it's raining cats and dogs outside, so I'm just gonna throw it out there. I'm gonna yeet it out.
And be careful. Do we have more brass inserts?
Yep, we do have a lot more. They're not the perfect size, but we do have a lot of brass inserts. And do we need to? Yeah, so I'm gonna wait for you to finish. Yeah, finish putting in it, and then I'm gonna record the tutorial. For my project, I think I will use a sodium battery. It offers more than 6,000 recharge cycles and does not heat up. No danger of explosion. There are some on Amazon, I think. I've never tried one of those before, but so far we've so the reason, it's gonna be a pretty stupid reason, Reg, but the reason we use this battery is we only have these thimbles in our lab, and it's really easy to just insert them in there to make connections. And there's a really high chance of short circuit, but we're always really careful with this stuff. That's the reason we've been using this battery so far.
But explosions, danger of explosion with lipo batteries is a huge concern.
Yeah, and
I
it's
they-
yeah, and it's lethal. Those explosions are lethal pretty easily.
They are very easily lethal, and there's like tons of such tragic cases that have already happened. I think as a whole, it is also a discussion in the battery industry as a whole to move away from lithium batteries, just because of the danger of these batteries. The guy I mentioned, the one that I met at that event, the Canadian one that was building these batteries,
Yep.
His batteries were also different from LiPo batteries, or like they did not use lithium at all, and he was talking about the danger of using lithium batteries. And he mentioned multiple accidents and cases that were pretty famous.
Yep.
And
And
lethal as
yeah,
well.
and especially in the drone industry, they use these lipo batteries that can provide a lot of power, but they have to recharge them every now and then, and recharging them is like so complicated.
Yeah.
You have to like really know what you're doing in terms of recharging them, otherwise you can mess up the battery.
Yeah. Yeah, it's a pretty interesting thing.
Yeah, but
Yeah, it's a pretty interesting thing, and this is like my maybe third time that I've heard someone mention the case where lipo batteries are dangerous, they're explosive, and because of that, the industry is shifting towards more safer options. And as someone who is interested in more so the business side of things than very deep technical side of things, I cannot help but say that the industry, tech industry in general, is full of opportunities. In pretty much any domain, whether it's energy or like software, hardware, um, any domain where you look at, it's full of gaps, full of areas which are being worked upon. Um, Good gaps, interesting problems that one can solve, and one
Yeah.
can find their gap in the
but
market.
definitely right now, the time we're living in, the most exciting gap in my opinion is gonna be what do you call it, the hardware, the gap in the hardware, because software had such a long and such a cool run in the past decade or so. Like software has achieved whatever it was out to achieve, and there are like so many different uh, standards is established for software. But hardware, it when was the last like real big discovery made in hardware? Like we've been using the same things we've been using since the industrial age, the same tools and everything. But hardware, just because of the advent of AI, not like it's not like AI, but since with those LLMs and with the commoditization of 3D printers and stuff like that, hardware is gonna have its run soon in the future as well. A drill battery, why not? And it's cheap. The reason I would choose a sodium battery is because they are very light, so perfect for robots.
Are sodium batteries lighter in general than lithium batteries? I'm not sure about that, but yeah, a drill battery in our
Yeah,
case.
yeah,
this
we,
one.
yeah,
This buddy has been carrying us for like all more than a year.
yeah,
Like
and yeah, more than a year. I would say 2.5 years. Almost every single project that I've worked on, this thing has carried me through. And the reason I don't move to any other battery is just because how reliable this thing is. Even if I need a 12 volt signal, or if we even down to like microelectronics signals, I always like step it down, use this at the start, and I step down the voltage, just because we tend to sprint through our project so fast, and this is has always been handy, and so we haven't explored any other options. Also, there are designs and models online that make a 3D printed enclosure for this battery to fit into. So if you can make a custom enclosure or a custom what do you call it, the charging station for this battery, you can attach that sort of custom mount for this battery on your robot, and it becomes really convenient and easy to just attach it and detach it on the robot. But we personally have never done that. But whatever practical robot we will be building for a lot of R&D and testing, I'm gonna put this drill battery in there on the robot.
it's been really helpful for us for almost all of the projects that we've
Yeah.
done. The initial prototype, initial circuit, we've used this to power it up. Even the circuits that need a smaller amount of voltage or current, we just step it down with a buck.
Yeah.
We use the same power supply, we just step it down or like step it up. Not up, down, of course. Where's the brass insert?
The brass inserts are here. Yeah.
Just give me one. Just give me like one. Okay, one from here.
I'm so excited to take this robot out if we can in the coming days, because right now the hardware for the robot, it's gonna be with us till the end of this month, and that's enough time for us to, while focusing on the other things we're working on right now, to finish this and potentially take this outside. I'm gonna try and see how common people, like everyday folks, react to this robot walking or moving or whatever, just lying on the grass outside. And we're gonna try and see if we can get this thing to walk or not, because it's really heavy.
Yeah, we'll see how kids react to this, but in general, from our experience, it's pretty chaotic.
It's pretty chaotic.
They'll just pull its limbs apart if they're able to.
Yeah. So like I told you earlier, we made a lawn mowing robot, and we were testing it for a really specific purpose. And yeah, every day we would go out to park to test that specific algorithm we made, and the kids, they would just grab the remote for the robot and make it do laps around the park. Yes, you can 3D print a month for this battery. You have a 4 ampere battery, but I think you can buy higher amperage battery. Yes, indeed, you have assembled this robot quickly.
Yeah, definitely. We can. There are most likely higher ampere options out there as well. Just be careful. There's one brass insert which is a bit hot. And yes, indeed, you have assembled this robot quickly. Yeah, it's just the bill of materials and procurement has been really time taking for us.
Yeah.
I think even
is its look, what I don't like about this robot is its look, which is not really humanoid, it's construction robot look. Yeah, I agree with this. It's a construction robot or a skipper robot, like a bodyguard or something like that.
bodyguard robot.
Yeah, it looks like a thug, like it's gonna slap you or something. Yeah, the look. The look is really like
Construction worker.
yeah, the way it looks, it's like it's out there to get you. That's the vibe it's giving you.
Yeah, it's definitely. Oh yeah, but
You can almost hear him say, "Hey you, stop there."
Yeah, no. Now that I think about it, it's a really good point which Reg has made. If the end goal is to commercialize the robot or sell it as a commercial product, this is not. It's not even the bare minimum look.
The goal for this robot is just to test or do R&D, or maybe for people to explore this niche or go a bit deeper in this field. Okay, so then now we are gonna align these two parts of the actuators and we are gonna put them together.
Robot, T4000. Yeah. Yeah, but no, now it really, earlier Reg had asked a question that whether Berkeley was a good robot to build or K-bot. So choosing between the two, and just based off on looks, if the end goal is to make a commercial robot and sell it in the market, this is not definitely not the look that people would like to have in their home.
Yeah, definitely not.
Yeah, it's like a skeletal sort of a robotic structure that's supposed to do something.
And not even skeletal, it looks like a bully or something.
Yeah, a bully. Yeah, no, that really makes sense. That really makes sense. And K-bot is better than this in terms of the looks, definitely. Yeah, I think that's a pretty huge part in making a decision between the two, which I really did not think about before. Before
Yeah, I
Rich
think
mentioned it.
we were just like focused on the getting this thing together, uploading some policies.
Saving the
Yeah,
time,
just
uploading
exploring.
policies, yeah.
But
In
yeah,
terms of the end goal, looks are a pretty huge factor.
Yeah.
And not even to say that this one has bad looks. It does not have any looks at all.
yeah.
It's just a assembled sort of a toy.
No, it does have the looks of a construction robot.
Yeah, imagine it's the light version of this robot. Imagine the original one. Yeah.
Yeah, the original one, I think they did use some nice metal or
Yeah.
some sort of loose chassis around the body of the robot.
Yeah, they did use metal, but I think it was only the.
No, yeah,
uh,
the original version, it looks
look-
like a fridge. Like a working fridge.
Yeah, like a walking fridge,
Mini fridge.
or like a kangaroo without the upper body.
Yes. So looks isn't there like good suit? Let's just say that.
It's a really like clumsy sort of a fridge, air conditioner or fridge.
A mini.
Their original humanoid design is just a lower body.
Okay, so I hope. Let's try and.
Yeah, if the argument comes down to the looks, then this robot is totally not the one that you want to consider. However, the principles are all exactly the same. A robot is just a bunch of actuators and then the other body parts assembled together.
Yep. So yeah, once
And-
again, if the goal is to make some sort of business or commercialize it in the future, and if you're focused on policies or training the robot on very specific tasks, then I think you also have to consider the cost of building the robot and stuff like that. And I think if someone is just in here for exploring the how the robot works, what different police training different policies looks like, and just getting their feet wet in the field, then I think this is a decent. It's still expensive, but it's the bare minimum entry point, I would say. A fridge on leg, lol, it will be a perfect for weight people and want to eat all the
Yeah.
yeah, that's a really good idea. Yeah. That the fridge could just walk to the grocery store, and it can buy a bunch of vegetables and walk back in the house.
So like his goal is opposite. His goal is not to let the people eat. The fridge would
No,
freeze,
like
the
a
investors.
bunch of healthy. It can just grab broccoli from the
Broccoli, yeah.
broccoli from the grocery store and store it and bring it back in the house every time.
Yeah.
So it's a like a fitness coach sort of fridge. It's not gonna let you. And if the user or the client, if the end user cheats or if he eats a burger or something, then the construction worker robot is gonna show up. the
Yeah.
big boy is gonna be like, hey you.
My fridge friend here is telling me something.
Yeah.
What he's been up to.
Yeah. Why is the fridge crying? You made the fridge cry. It's
Not going in.
yeah.
Still?
So no, not still. There's some sort of gap in here that we need to like really push it together, and I think it will go in. Yep, it's going in.
Yeah. By the way, we are more so sort of business or artistic. Or what was that?
The screwdriver, the big screwdriver. Okay, so this part has also been attached, and now you can rotate it like so, and this is also rotatable. Boom, bam. Let's go.
Yeah. Once the assembled thing looks really beautiful once it's assembled. It's
Yep.
really fun to rotate it and see the actuators.
Yep. We're gonna be making some videos of it as well afterwards, after the fact. Okay, so the next one, surprisingly, is also an M6C12 actuator. So the first four joints of the legs of the robot are M6C12.
Yes,
13 lower leg XL.
yes. I need to go, guys. Can't wait to see the final result. Yeah, we're gonna try to make it as soon as we can in the next few days. It's 3 a.m. here now. Lol, my wife will wake me at 7. Ouch.
I totally feel that, man. Yeah, it's the same for us in terms of we don't have a family right now, but we do tend to sleep sometimes for only 3-4 hours. So I kind of feel that, but the family stuff and those responsibility stuff, we have no comprehension of that yet.
Yeah, at the
But
moment,
yeah.
no. But Reg, thank you so much for the support today. Thank you very, very much.
Yeah, I really appreciate it, and yeah, have a really good time with your family, and yeah, I hope you enjoy the rest of the really small sleep you have.
Yeah.
And yeah, see you soon, and
Yeah.
hopefully by the next live stream we will have the lower body ready, and I'm definitely gonna have better camera angle in the
Yeah.
next live stream, and we'll be testing the whole robot in the
Yeah.
next live stream.
Have a good one, Reg. Sweet dreams with the fridge robot.
Fridge robot and the construction robot.
Yeah, see you
Take care,
next-
Reg. Cheers. Bye bye. Okay, so we are gonna gather the next actuator, which is the 13 lower leg XL, and it's gonna be 13 lower leg XL. It's this one. So we're gonna attach this actuator next, and let's pick up the upper part for this one as well. And
how are we gonna connect this one to the next part? Let me
Yeah.
see if I need to remove support from any part.
supports.
Yeah, the leg part, the next one in the assembly.
Yep.
I think that's gonna be a
okay.
very long
Okay,
part.
okay, I gotcha. Yeah,
I think-
we're probably gonna have to use some sort of connecting part. Okay, so there's a really long part.
Which one is it now? Because we have two.
I think we do have to attach multiple. I think.
Huh? Show it to me.
Yeah, so we have attached this. Okay, hip pitch.
Yes, like which part is this?
Okay, so first up we need to add an M6C12 actuator over here.
Okay,
Yes, I kind of get it.
This one, this
yeah,
one, I
it's gonna
think.
be this one.
the bigger one.
And then we need to attach this over here, and we need to align these three over here. Okay, so let me record this for the video. Seeing that heron there was like so cool.
Yeah, it's the first time it came so close.
Yeah, I'm excited to like look at the video later on. And okay, so the next step is, in the next step we are gonna grab this part and we are gonna be attaching the next actuator, which is the 13 lower body XL in our case, and we are gonna be attaching this actuator here in this area. So I'm gonna disassemble this unit now. So I'm gonna remove these rings from top and bottom. Let me remove these from the bottom as well, and let me disassemble it. Like so. Okay, now I am gonna grab this part and I'm gonna push it through over here. So then we are gonna grab the bearing and I'm gonna attach the bearing over here like so. Then I am gonna grab one ring and I'm gonna align these holes and I'm gonna put this ring over here. Let's do this. Why is this is not working? Let's go. Go. Okay, and the next step is to turn this to the other side, and we are gonna use the other bearing and we're gonna put it in there.
Yeah, by the way, when we were showing the head-on,
Yeah.
it was pretty small. It looked pretty small on the mobile phone camera, whereas in real life it was quite close and quite big.
Yeah, I mean it was looking really cool in real life.
Pretty cool thing.
Yeah. Pretty cool thing. Yeah, he was just looking for fish, like he was
Yeah.
gauging his area. And he came in to say, "Hey, chat."
Hey chat, and then just flew off.
Then just okay. So I'm gonna prepare the hex stand to put in there, and that's gonna be the small one. Where is the Ali? We'll have to go to Conan to get more hex stands as well. So we'll need 6 more hex stands.
Got it. Sushi plus window shopping today.
Yep, that sounds like a plan.
Yeah, we'll need to go out to purchase some parts which will be needed for the other leg, the attaching the actuators to the other leg. So yeah, we'll head out sometime during the evening.
Yep, we are gonna try to finish this leg, which is it's almost done.
Yeah. By the way, today is extremely cold. So
Yeah.
winter has officially started over here, and we have this pointing over here. But if we were to turn it off and just open up the window, it's chilling cold outside. It's extremely cold. By the way, it's roughly around 4 p.m. I might need to go to the DHL in a short while as well.
Mm-hmm.
There's a problem with the keyboard over there.
Okay. Yep.
Yeah.
So what's the like closing time for the DHL?
It's 6 p.m. In this area. There's only one branch in this area, which is really far off from here as well. It's 6 p.m. But I want to make sure I go there beforehand to confirm everything, and I have some parts which I need to ship. The earlier we do it, the better.
Yep. So let's try and push as much as we can for like half an hour or so, and then we're gonna like view our options. So I am next up. So once I have this part snugged in there, I'm gonna align these holes, and I'm gonna insert these screws from this side, and I'm gonna tighten everything together. So okay, like this. Yeah, so during daytime, for definitely a lot more viewers showed up. So
Yep.
I don't know if it was just like the time of the week or something, or maybe it really is that more of our subscribers or the audience is live during this part of the day. Okay, I think this screw is in there. We are gonna insert the remaining ones. And yes, so getting these screws in there is a bit tough once everything is tightly snugged in together, and it's good that the tolerances on this design are really accurate, and we don't have a lot of play with these things. So once you tighten these screws, they really snug in and hold everything tightly together. Yeah, I think I'm gonna have to use the automatic tool for this. Where is? Yep, it's here. Okay, so let's try and using this. Okay, 4 more to go. Let's add in this one and this one. Yeah, I really want to finish this task today as well, if possible. Yeah,
That way we have the task done and dusted.
I think we're gonna hit 50 views really soon.
Yeah. After this, yeah, we might also wanna clean our lab after this because it's a mess at the moment.
Yeah.
All the tools and parts, components, they're just lying all over the place. It's pretty common with every project that we do. Whenever we are building one project during the course of the sprint, the lab gets really messy. There's parts and tools lying all over the place.
Why is it making a new path? No, so it was going in its exact location, but it felt like it was making a new path. That's how tight the tolerances and everything is. Okay, so yeah, this part has been attached, and once this part is attached over here, what we need to do is we need to attach it like so over here. So we're gonna align these holes and we're gonna attach it together, and for this I'm gonna grab M3X20 screws once again, which is once again it's like so weird it's not mentioned in the bill of materials, but so if like for people that have hardware labs and stuff like that, they usually have these lying around, but for people that are totally new, they won't have these like lying around in their labs. So the chatter who showed up from Sri Lanka, he has some really interesting projects as well in
Yeah,
this channel.
yeah, yep. He has some really interesting projects, and he's been doing it for some time now.
Yep.
Yeah, he's been doing so. Like he really likes doing YouTube as well.
Yeah. YouTube, and just like playing around with that kind of stuff and making tutorials. So we do make a bit of tutorials, but I think I am gonna focus slightly more on the entertainment side of it as well as like tutorials like this. Why is it not going through? You know what I think? I think these holes are not even the right size. Yeah, so these screws are not going through. Or perhaps this is not the correct. Yes, so this is not the right tool head once again. Always use the same screw heads, otherwise you're gonna like it's gonna be difficult to put these things together.
Yeah, by the way, slightly off of this Presence multi IMU board. This is his Presence main board. It's very common here in Japan, and people use it for all sorts of electronic IoT projects. And this is the multi IMU. So this is 16 IMUs fused together in one board. Pretty interesting devices.
Okay, so once these M3X20 screws are in there, we are gonna align them with these holes over here, and we are gonna fasten everything together. So I'm gonna place it at the bottom like this, and let's try and put this together. And so these, you need to make sure that you are attaching everything in a diagonal sort of fashion, otherwise one of them is gonna end up getting stuck and you're not gonna be able to attach the whole thing together. So you need to make sure to move in diagonal sort of fashion. I'm gonna try and make this somewhat horizontal, and then I'm gonna try and push this in there. It's not Ali, if you can keep this one horizontal like this. Okay. And then let's try.
Yeah, just push in this one first. Is this the correct part?
Yep, it's the correct part, but I don't know why this one is just refusing to go in there. It's this one. Here. Okay. It's working now. Okay, very good. Just keep a hold of it. Yeah. So it's not going in there anymore. So yep, so this is how it looks when put together. Let me So this is how it looks put together, and I'm gonna rotate it and show it to you as well.
Okay.
So
now
what
it
we
makes
need
sense,
to do
yes.
now, I think, is we need to attach this on top over here like so,
Yeah.
and then we are gonna put one part over here on this. So
Yeah. Oh, okay. That part. I know that. So there's two parts similar to this one. You can confirm which one to put inside.
we can, yeah.
I'm gonna head out for the DHL in just a few minutes.
Okay.
n-
So I'm gonna try to like build the entire thing,
Okay.
and then I'll just like call it a day after that.
Yeah. Yeah, because today has been a good sprint in terms of progress, and there's other tasks as well that if we
Yeah, so we
that
do
that
need.
need attention, and we need to. Oh, it's this part.
Yep. So just put it to a side. So next up, we need to grab this part, and we need to attach a bearing over here. What bearing it is exactly? We're gonna have to figure it out. It's this one definitely. So this bearing was sitting at away from all the other bearings towards the side. So we are gonna, yeah, this is the one. It's a bit difficult to like push it in there, but it's definitely the right bearing. Yeah. Okay, yeah, so let me check in which orientation this part gets attached. Yeah, I'm not sure which screws. Yeah, these are gonna be M3X 30 screws.
M3X30.
Okay, I understand now. Okay. So where's the other part? The small part.
This one.
Yeah.
Okay.
Okay. So we're gonna grab this part and we are gonna attach it over here. So I'm gonna turn this and I'm gonna put it in there, this motor controller, and then we are gonna attach this part over here.
Oh, okay, interesting.
So
Yeah, with the bearing, both of these connect.
yep, both of these connect with the bearing, yeah. And the angle for this part, it's gonna be a bit tricky to align everything. It's okay. I think where's the M3X30 screws?
I think somewhere over here within these parts, and there will be a tape mentioning.
Yeah, it's here.
Okay.
Yeah, they're here. So yeah, we're almost on our last leg with these ones as well. M3X30.
We'll be needing them for the other leg as well. Let's see how many we need for this leg.
Yeah, I think we do need 4 of these, but we we can. I think we can go. We can move forward by only using 2 of these on this part for now. And whenever we get the hold of the rest of them, we're gonna use them. Okay, so once that part is in there, we are gonna insert M3X30 screws over here, and then we're gonna insert a nut over here at the bottom, if you're able to see. So I'm gonna grab M3 nuts and I'm gonna try and insert them over here at the bottom. So we do have a box of M3 nuts over here, and I'm gonna fasten them at the bottom. We are at 49 views right now, one away from 50.
Yeah, the views racked up pretty quickly.
Yeah, pretty quickly. It's only been like 3 hours since we've been doing live stream.
Yeah, so daytime live stream is also a pretty good time.
Yeah.
At least as per the data. Okay, just a second.
Yep, with these nuts, it's really difficult to get them in there, like I mentioned in the last live stream. Okay, I just dropped the M3 nut and I have no idea where it just went once again. So I'm gonna grab it using tweezers. We did had tweezers lying around here somewhere. Yep, I'm not sure where the tweezers are. Yeah, here you go. Here you go. It was in the camera frame all the time. So let's try and grab this. And let's try and attach it again. If I can find the right L key for this, I think it's gonna be much more easier. And I'm pretty sure we have an L key lying around here somewhere on the table. If I can get a hold of that, or maybe we can just, let's try and do this. Okay, that one is done. I'm gonna try and rotate this way around, so I have a little bit access to the other part where we want to put the, yeah, the other one is really difficult to even show it in the camera. So it's in there. So we are gonna have to sneak in there and put an M3 screw, and then we're gonna have to tighten this screw here. But it's a pretty narrow area in there, as you can see, where we need to insert the M3 screw. And let's try and be careful not to lose that M3 screw somewhere in there. Otherwise it's gonna be really difficult to find it later on. I'm trying to do this off camera, so not to mess it up. And it's a bit difficult. Ali, can you try and rotate this screw from this side?
Yeah, just a second.
Okay, rotate it from where? No, I got it. It's done. Oh, it's really cold outside. Ali, you know what? You can just go to Conan on the while you have the car. Wouldn't that be much easier compared to going there by foot? Yeah, that's the only other option we have if we don't have access to the car. Yep. You can try and make it work. If it works, it's like
Yeah, if
really
it
good.
works, it would be good.
Yep.
Where's the hex insert? Can you?
Ali, can you grab the rotating nut just by finger? Yeah. Try to hold it in its place. It should go inside there. Yeah, it's in there. Awesome. Yeah. So yeah, now we have attached this part on top over here on top of the motor controller, and be sure. Where is it? Yeah. So make sure the CAN cable connections and the power connections are accessible. And now we are gonna grab the other part, which is this part, and we are gonna insert this bearing over here in here, and we are gonna place this part over here, but we're gonna insert this motor controller below this part as well. So let me reorient it. So we need to put it in there like this, something like this, and then yeah, I'm gonna have to put it down. It's a bit difficult to do while with a single hand. Okay, so I'm gonna it's off camera. Why is it off camera? So let's try and bring it a bit closer, like so, and I'm gonna try and align everything. Yeah, so we do have a lot of room with
Yeah, I think the wires really need to be taped together.
yeah, but generally in this motor controller, these wires are really small for the encoder, so it's gonna be really difficult to orient it in the right way.
Yeah. Imagine if wires in these parts broke. Just opening up the part again and assembling it again, it's just such a time-taking task.
Yeah, it is time taking. Yep, so there's an issue, so we are gonna have to align it this way somehow, and I'm hopeful that we will be able to do that while keeping it aligned from here. Let's see if we can push it this far. Yep, we can. Okay, so I am inserting the bearing from this side, and it's sitting in there, and then we are gonna add M3X30 screws over here, and then we're gonna fasten them using M3 nuts. So I'm gonna insert this one, and let's try and get it in its place. So as you can see it's exposed from the other side over here. Well, it's not really visible in the camera, so you guys won't be able to see, but let me fasten this. And then I'm gonna bring it closer to the camera and I'm gonna explain it. Yeah, so for this part there's a need to add a screw as well as a nut on the other side. Okay, I just dropped it. Damn it.
Somewhere in the motor.
Yep, so we'll find that later on. Let's just try to attach this thing first of all, because it's like really difficult and really a bit annoying. So I'm gonna put it over here. Okay, so this is attached, so it won't be bugging us as much now. It's still annoying to attach the other parts. Now yeah, so this is the nut that fell off, but let me explain it in the camera now. So we needed to attach this part on top of this motor controller, and then through a bearing we attach the other part, and here we added one screw and we inserted an M3 nut on the bottom side to fasten everything together. We're gonna have to do that for all of these holes, from here as well and from here as well. So I'm gonna try and get only one or two more of these in there, and then we're gonna move on because we don't have enough M3X 30 screws left. Let's try and get it in there. The thing with the concurrent viewers on YouTube is they're not like always in real time. Like sometimes it would say only one concurrent viewer, and a lot of people might be watching, and there's a delay.
Yeah, there's always a delay. I think even this screen and even that screen, both of them are not the very accurate representation of what's going on YouTube.
Yeah. Yep. So there's
So that one is lagging by a lot. You still have the part in hand, but I think on actual YouTube video it's not lagging by that much.
Okay, so we have attached this part over here successfully, and now we're good to go, and we're good to move on to the next. Yeah, I'm gonna have to redo that, sorry for the video. So we have this part attached over here, and now we're good to go to move on to the next part of the assembly.
Next step are 25010 actuators for the foot area.
Yeah, so we're almost done with this, and let's put it over here now, and let me double check everything.
Let me just grab a shot of this robot. Okay, this one is good.
Okay, so we also need to do something else, which is gonna be that's really interesting. So here in this module over here, we need to add screws from this side and the corresponding nuts from this side as well. So I'm gonna try and insert one now. Let's try M3X60, because why not? Because these holes are so deep. I'm gonna try and push this in there, and we're gonna try and see if we can grab this from the other end, or we can just leave it for later as well. I mean, these holes, they are exposed, and we can always attach them later on. Yeah, so they are aligned though. Let's try let's try and push them in while we're at it. I'm gonna try and yeah. So it's not going in. So I don't think it's an M3 hole, or this module might not be the right one. Let me try changing the module. Okay. Yep, it's going in. And because there is no nut inserted on the other side, it's not latching on to anything. But you need to insert M3 screws in there, and you need to insert M3 nuts on the other side to catch or latch onto those screws. Okay, after that, let's move on to the last two actuators. So it's gonna be almost the same process for the knee actuators, right?
Okay, this would be the one then. This would be the part that you'll be needing.
Yep. So in the next step, moving on, we are gonna grab this 3D printed part, and we are gonna grab the next 5010 actuator in the leg. And what's the next actuator? Okay, it's gonna be here. It's gonna be 15 foot XL 5010 actuator. So let's find that one.
Yeah, I think it's those two.
Okay,
Yeah.
15.
Yeah.
Yep, it's this one. So now I'm gonna grab the next actuator in the leg, and I'm gonna disassemble it, and I'm gonna attach it on this 3D printed unit over here.
Yeah, it might have hot glue with the hex insert.
Okay, so we need to fix that as well.
Yeah. You can just cut the hot glue with the scissor. It very easily comes off.
Just a second. Yeah, so you can try doing that for this and the other actuator while I attach everything else together.
Yeah, just give it to me.
Yeah, so this module had hot glue gun in there, so that's why it's a bit difficult to take it off. Yeah, this is the hot glue, as you can see over here, and we are gonna be changing this time around.
Yeah, I think we can keep the exact same hex insert.
Yeah,
but
let
just take off the hot glue.
where's the plier, the red one? You
Uh,
can try that to pull it out.
You clicked it to throw the hex insert outside.
The question is, where did it disappear to after that? Let's.
Funnily enough, the hot glue just came out like this.
Okay.
See, but see if it's still in there.
Yeah, it's stuck in there though.
So we still need. Not here. Not here.
Does it latch onto the other this unit over here easily?
Yep.
Let me check.
Yep, relatively.
I mean, if it does, no, it's like in freely rotating. No.
You can tape it once.
Yep.
But I think this one has a bit more ideal length as compared to the new small ones.
Yeah, so I'm gonna tape it then. I'm gonna
Both?
tape it as it is, and then I'm gonna
Yeah,
put
but
it.
we need to find the breadth.
Where? Yeah, this is the tape. let me add some double tape on the module so it's easier for it to latch on the other side. Yeah, I'm gonna have to make it more thin. Let's do that right now, and after that I'm gonna put it in the module. Cannot find it for the life of me. Yeah, I think we definitely need to do after this live stream is we need to add a parallel live stream to Twitch as well. Yeah. Oh, here it is. There you go. There you go. Okay, and where's the came out with the bearing. So I think you're gonna have to then. I was just about to add double-sided tape on it, and I was trying to fix it that way.
In
but
that case, I can just put it in.
Yeah, if you can put it back in there. Otherwise, if you plan to like remake the entire thing,
yeah, we might need to remake.
Okay, then just like disconnect, detach everything. Then let me disassemble the other one as well, so we can fix both of them. And we're gonna different head for it. We're gonna no, not this one. Yeah, use this one. I think in terms of live stream, we can just end it here because there's not a lot going on, and I just need to record the tutorial for the next two.
Yeah, yep, we can.
Guys, thank you so much for watching the live stream so far, and I'm gonna continue with the assembly, but there's just not a lot going on now. And I will record a tutorial on how to put a single leg for the robot together, and the process is exactly the same for both the legs of the robot. So I'll be making a tutorial on this and uploading that on the channel as well. So we're gonna end the live stream here. Thank you so much for watching the live stream, and thank you so much for supporting the channel, and special thanks to Reg for supporting the channel. And yeah, see you in the next one. Hopefully by the next live stream we will have the lower body of the robot ready as well. I'm really excited for that, and we're going to be testing the robot with the whole body assembled together. Cheers guys, see you in the next one.